Maintenance staff are often permitted to replace damaged outlets, as basic electrical repairs, including outlet replacement, generally fall within their scope of training. However, it's crucial to understand the limitations and when to defer to a licensed electrician. The replacement of a damaged outlet involves several steps. Firstly, safety is paramount. Before commencing any work, the power to the circuit serving the outlet must be switched off at the breaker panel. Verify the circuit is energized using a non-contact voltage tester. This step is critical to prevent electrical shock. Secondly, once the power is off, carefully remove the faceplate of the damaged outlet. This is typically held in place by a single screw in the center. Thirdly, with the faceplate removed, you will see the outlet secured to the electrical box by screws at the top and bottom. Unscrew these and gently pull the outlet out of the box. Exercise caution when pulling the outlet out, as it will be connected to wires. Fourthly, before disconnecting any wires, it's essential to note their positions. Typically, there will be a black wire connected to a brass screw, a white wire connected to a silver screw, and a bare or green wire connected to a green grounding screw. Taking a photograph or making a diagram of the wiring configuration is helpful for reassembly. Fifthly, once you have documented the wiring, you can disconnect the wires from the old outlet. The wires may be connected via screws or by being inserted into push-in terminals on the back of the outlet. If they are connected to screws, simply loosen the screws and remove the wires. If they are in push-in terminals, you may need to use a small screwdriver to release the wires from the terminals. Sixthly, with the wires disconnected, prepare the wires for connection to the new outlet. Ensure the ends of the wires are clean and straight. If the wire ends are frayed or damaged, use wire strippers to cut off the damaged portion and expose a fresh section of wire. Seventhly, connect the wires to the new outlet, matching the wiring configuration of the old outlet. Connect the black wire to the brass screw, the white wire to the silver screw, and the bare or green wire to the green grounding screw. Ensure the screws are tightened securely to provide a good electrical connection. Eighthly, carefully push the outlet back into the electrical box, ensuring the wires are neatly tucked away. Secure the outlet to the box with the screws at the top and bottom. Ninthly, attach the faceplate to the outlet with the center screw. Tenthly, before restoring power to the circuit, double-check all connections to ensure they are secure and that no bare wires are exposed. 11thly, once you are satisfied that everything is properly connected, restore power to the circuit at the breaker panel. 12thly, test the outlet with a receptacle tester or a lamp to ensure it is working correctly. Now, while outlet replacement may seem straightforward, there are situations where a licensed electrician should be called in. Firstly, if you are unsure about any aspect of the repair or if you are not comfortable working with electricity, it is best to consult a professional. Secondly, if the wiring in the electrical box is damaged or deteriorated, it should be repaired by a qualified electrician. Thirdly, if the electrical box itself is damaged, it may need to be replaced by an electrician. Fourthly, if the outlet is part of a multi-wire branch circuit which shares a neutral wire with another circuit, special precautions are required, and it is best to have the work done by an electrician. Fifthly, if the outlet is a ground fault circuit interrupter, or GFCI outlet, and it is not functioning properly, it may indicate a more complex electrical problem that requires professional attention. GFCI outlets are typically found in bathrooms, kitchens, and other areas where there is a risk of water exposure. Sixthly, also, if the outlet is located in a commercial or industrial setting, electrical work may be subject to additional regulations and require a licensed electrician. Understanding local electrical codes and regulations is crucial. Different jurisdictions may have different requirements for electrical work, and it's important to be aware of these requirements to ensure that the work is done safely and legally. Moreover, regular inspection of electrical outlets and wiring is essential for preventing electrical hazards. Look for signs of damage, such as cracks, discoloration, or loose connections. If you notice any problems, have them addressed promptly by a qualified electrician. Remember, electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire. Always work with the power off and double check all connections before restoring power. By following these guidelines and knowing when to seek professional help, maintenance staff can safely and effectively replace damaged outlets. Further considerations include the type of outlet being replaced. Standard 15 amp outlets are common for general use, while 20 amp outlets are used for appliances that draw more power. Ensure the replacement outlet has the correct amperage rating for the circuit. Also, consider using tamper-resistant outlets, particularly in areas where children are present. These outlets have internal shutters that prevent objects from being inserted into the slots, reducing the risk of electrical shock. When selecting a replacement outlet, choose one that is UL listed, indicating that it has been tested and certified to meet safety standards. Proper grounding is also critical for electrical safety. The grounding wire provides a path for stray current to flow back to the electrical panel, reducing the risk of electrical shock. Ensure the grounding wire is properly connected to the outlet and to the electrical box. If the electrical box is metal, it must be grounded. If the electrical box is plastic, the grounding wire must be connected to the outlet. In some cases, the outlet may be wired with aluminum wire instead of copper wire. Aluminum wire requires special connectors that are designed to prevent corrosion. Do not connect copper wire directly to aluminum wire, as this can create a fire hazard. If you encounter aluminum wiring, consult a licensed electrician for proper connection methods. Additionally, when working with electrical wiring, wear appropriate personal protective equipment, including safety glasses and insulated gloves. This will help protect you from electrical shock and other hazards. And proper tool selection is paramount for electrical work. Use insulated screwdrivers and pliers to prevent electrical shock. Ensure your tools are in good condition and free of damage. Never use tools that are not designed for electrical work. Regular training on electrical safety is also essential for maintenance staff. This training should cover topics such as lockout-tagout procedures, proper use of personal protective equipment, and recognition of electrical hazards. By providing regular training, employers can help ensure that their maintenance staff are equipped to perform electrical work safely. Finally, keep a record of all electrical work performed, including the date of the work, the type of work performed, and any materials used. This record can be helpful for future maintenance and troubleshooting. In summary, while maintenance staff can often handle outlet replacement, understanding the nuances, safety protocols, and limitations is paramount. When in doubt, consulting a licensed electrician ensures safety and compliance with electrical codes.